Dear friends, architects, engineers, once again into VK Jain Sir ki MEP classes. This is the fourth module of glare in lighting systems. It's a very important topic for architects and consultant engineers as to how to avoid glare in lighting systems. Friends, I am discussing daylighting currently as contrast to artificial lighting that we normally know as lighting. Daylighting has been a primary means of interior illumination since the first buildings were constructed. Full use of natural daylight can displace daytime electrical lighting energy consumption in buildings, resulting in considerable avoidance of building energy operating cost. We can save a lot of money by providing proper daylighting arrangements. Designing for daylight illumination is an ancient art, enhanced considerably in the modern era by improved materials, construction techniques, and computerized design and performance evaluation tools. Artists have known for centuries that natural daylight offers the best illumination for good color rendering of paintings and other objects. Now it is possible in many climates to use larger window areas than in the recent past for the aesthetic view, illumination and health benefits these possess. Without the adventure way consequences large windows once represented. Dear friends, uh, daylighting as per energy conservation building codes ES, ECSBC recently in 2023. Daylighting in the energy conservation building code is a mandatory passive design strategy requiring above grade floor areas to achieve minimum useful daylight illuminance UDI, typically 30 to 60% of annual potential daylight hours depending on the building type and compliance level. Key requirements include mandatory area requirement, ratios of daylighted area to total above grade area must be met for businesses, education, healthcare and retail building. Now this is mandatory in the sense that mm, the this particular code is in vogue if you have power requirement over 1000 kVA, 125 kVA, which normally happens in any building which is of height more than 15 meter. The second requirement is through controls. Daylight area must have an automatic manual control to shut off or dim artificial light when natural light is sufficient. So all area in the buildings and the rooms having more than 30 square meter and facing the daylight should have a arrangement for controlling the daylight by dimming it uh, after observing if sufficient natural light is available. Performance metrics. Compliance is measured based on the percentage of UDI 40 to 60 for ECBC, ECBC plus and super ECBC during daylight hours. You know, matlab, this normally you are supposed to construct minimum ECBC compliance building, but you can always go for ECBC plus or super ECBC, which needs more money. Energy efficiency. Proper design reduces lighting power consumption and mitigates solar heat gain. Crucial for compliance with ECBC 2017/2024 standards. Friends, solar lighting system performance can be reviewed by illumination, and second is by energy value. When we talk of illumination, we talk of quality, color ranging index, and glare avoidance. Now, glare avoidance is the main subject of this uh, present representation. Now, quantity of illumination, that means illumination level, illumination light level, and coverage area, all this to give user satisfaction and productivity. Uh, in case energy discussion have displaced electrical lighting, direct energy savings. In case thermal energy impacts, solar gain and conduction heat transfers. They are very important for air conditioning. Net energy impact, cost and annual rupees savings. Friends, now we are discussing glare. Glare is a common lighting problem. Glare is what happens when a bright light source or reflection interferes with how you are seeing an object. In most cases, your eyes will adapt to the brightest level of light. When this adaptation happens, it becomes harder to see the details in the duller or darker areas of the workspace, even though they are actually sufficiently lit. Glare can cause annoyance and discomfort and can actually decrease a person's ability to see. Reflected glare is caused by light reflected from polished, shiny, or glossy surfaces. Second, glass on picture frames or windows at night. Third cause may be monitors and screens. Direct glare is caused by very bright light from poorly positioned light fixtures. Next cause may be sunlight. Very in say noon hours, the sun is very bright. Friends, now we can see The effect of glare on a person working on computer screen. The figure on left hand side shows three different mounting of fluorescent tube or LED tube fittings. Uh, you can always judge which is better. Now, reading tasks, avoiding glare in reading task. Suppose three luminaires are to be mounted below the false ceiling area. 3 points A, B, C are shown in the diagram. To have proper glare-free environment while designing a drawing task on computer screen, and operator sitting on chair in erect position, the fitting layout is proper. Friends, the diagram on the right hand side of this slide shows four different cases. Uh, for correcting glare, the designer can try using several small low intensity light fixtures rather than one large high intensity light fixture. Second measure may be using light fixture that diffuse or concentrate light well. Indirect light fixtures or direct light fixtures with parabolic levers are two possibilities. Third, covering wear valves with levers, lenses or other devices to control light. The fourth measure to correct glare, increasing the brightness of the area around the glare source. Fifth measure is using adjustable local lighting with brightness controls. Sixth measure may be position light fixture to reduce reflected light that is directed towards the eyes. This one, fourth case. Friends, when we talk of glare, we talk of contrast also. Contrast is the relationship between the brightness of an object and its background. A luminance meter to is used to calculate contrast and provides a number between 0 to 1. The average contrast should be above 0.5. Contrast can be measured as per formula given on the top of the slide Y. The contrast is defined as luminance object minus luminance background. That means luminance of object minus luminance of background divided by luminance of background. Friends, this particular diagram is labeled with different type of numbers in internal enclosed atmosphere and external. We'll discuss one by one. Uh, First, this is a private office. Second is in open office. Third is provided with sunset with building integrated photovoltaics. Fourth, roof with building integrated photovoltaics. Fifth is skylight. This one. Sixth, energy efficient and occupancy. This one. Seventh, electrochronic glass. Using electrochronic glass. Seventh. This one. Seventh, radiant heat floor. The floor is designed for that. Eight. Then ninth, natural ventilation. Tenth is high performance glass. This one. 11th is reduction of outdoor light pollution by providing this sunshade. 12, water efficient landscaping. This one. 13th, ground source heat pump. This one. Friends, now we are discussing discomfort glare. Discomfort glare usually results when light entering the eye from side is much brighter than that coming from the visual task. This extra bright light is mentally and physically confusing and can result in visual fatigue, discomfort, and even headache. Buildings have several potential sources of glare. Beam sunlight entering the eye directly perhaps as the worst possible due to the due to its extreme brightness. Both specularly and diffusely reflected beam sunlight also can produce both kinds of glare. A bright window surrounded by dark walls and furnishing nearly always produces discomfort glare unless the light from the window normally does not enter the eye due to orientation of the visual task. Where electrical lamps, either incandescent or fluorescent, can produce glare, as can purely designed electric luminaire. A successful lighting design will reduce or minimize the system's potential contribution to both kind of glare, whether it is a daylighting or by a electrical lighting system. Friends, disability glare will be discussed with respect to this diagram. Disability glare is produced with a strong source of light that masks a visual task, usually by reflection, reducing this reflection, reducing its contrast and disabling the person's ability to see that task well. Reorienting the task and glare source often can ameliorate the problem, as can reducing the brightness of the source. Friends, the diagram on the right side um, make you understand that discomfort glare is produced by the strong light from the side entering the eye without masking the target directly. Friends, the diagram on right hand side illustrates a small bright window, this one, and dark surrounding, this. produces maximum glare, whereas a large bright window, this lights surround minimum glare. Friends, this particular slide shows the daylighting arrangement made in a industrial atmosphere, maybe some sort of factory. Now, daylighting design. The goals of good daylighting include the provision of good quantity and good quality daytime interior illumination and view, coupled with high visual comfort for occupants. Happy people are productive people. It is necessary to prevent common problems such as unwanted glare and overheating from excessive direct beam illumination. In the process of providing good quality illumination of adequate quantity, it is desirable to design the system so as to displace as much daytime electrical lighting as possible to minimize the energy cost to building. Now, in this one, you have a daylighting window here provided with glass. Here in this, you can provide daylighting arrangement like this. In this case, you have from the top daylighting arrangement as shown by arrows. This shows bilateral lighting section. That means light coming from both sides, here and here. The bottommost shows roof monitor lighting section, this here. This is a diagram which shows sawtooth lighting section. The roof is provided in a sawtooth nature and maximizing the daylight here, here and here. And atrium lighting section may be provided like this. This glazing, the skylight lighting sections are provided here, here, or in this here. This is another slide which shows daylighting arrangement being made in industrial buildings. Here you can provide sawtooth glazing arrangement like this. In this one, you have a shaded side illumination glazing, and you have sun breakers provided to guide natural light in and providing window shutters. Friends, now we are discussing direct glare. Direct glare is caused by excessive light entering the eye from a bright light source. The potential for direct glare exists anytime one can see a light source. With direct light, when you are able to see the light source directly. With direct glare, the eye has a harder time seeing contrast and details. A system designed solely on lighting levels tend to aim more light directly towards a task, thus producing more potential for glare. The effective use of indirect light minimizes the negative effects of the direct glare. In some circumstances, such as entries and checkpoints, glare can be used to increase vertical illuminance on approaching vehicles or individuals while increasing visibility for guards and patrols. This is case of street lighting. Causes of direct glare include an exposed bright light source, for example an HID highway luminaire or an exterior floodlight. Overhead T5HO fluorescent lamp in a downlight also can cause direct glare. Direct glare can be minimized with careful equipment selection and placement. In interior applications, indirectly light light the walls and ceilings. A limited amount of direct light can provide ascent and task lighting. In exterior applications, use fully shielded luminaires that directs light downwards towards the ground or a building facade. Friends, all the four diagrams here explains the direct glare. Here you can see the fittings or luminaires provided directly on task or working area. Similarly here, the downlighters having metal halide lamps provided in a billiard or some such games, what it may provide glare. Here also external daylighting reflections, and this one also a light source producing direct glare. Uh, Friends, now we are discussing indirect or reflected glare. Indirect or reflected glare is caused by a light reflecting off the task or pavement in such a manner that contrast is washed out. Many work situation positions also produce reflected glare on wet pavement, washing out lines on the road. Reflected glare will limit one's ability to see contrast. Like direct glare, indirect glare can be minimized with the type and layout of the lighting equipment. For interior applications, locate direct light to the side or behind a critical task. Use semi-indirect light to bounce light off the surfaces in order to provide uniform low glare light with less reflected glare. For exterior lighting, direct the light away from the observer with the use of low glare fully shielded luminaires. So thanks friends for coolly watching my presentation.